tonight class. Yeah, tonight we'll be talking about indices, Mth112, indices. Please don't forget to write in the attendance. We'll be talking about indices. You know very well that you were taught indices, all of you, in your secondary schools, two of us. Yeah. It's not new. It's the same approach, but at least something advanced will be added to make you strong mathematically. Okay. Indices, you know, in indices, before you be able to solve problems from indices, you must know the laws of indices. We have one, multiplication law, division, and power law, 0 laws. We are going to look at one after the other. Is that clear? Now, when we have an expression of this form, a raised to the power of x, n, you don't need a prophet to tell you this is in the form of indices. Is that clear? So let us now consider the laws of indices. As I said, we are going to start with multiplication law. Amen. Laws of indices. Laws of indices. 1. Multiplication law. Multiplication law. Amen. Okay. I know multiplication law is trying to tell us that if the bases are the same, we can add the powers. That is, if we have a raised to the power of n times a raised to the power n. Amen. Please take notes. This is not a raised to, that is an. I know some of you write an. This and this, they are not the same thing. This is an, while this is a raised to the power of n. Is that clear? Are you following? So don't write it in this form. This and this, they are not the same thing. Please take note. So you can now see that we have a. We call this the base. That is a raised to the power of n. This is known as base, and this is known as power or index. Amen. Okay? Yeah. Are you following? Okay. Yeah. So as you can see now, this is base A, this is base A, two of us. So it implies that, according to the multiplication law, it implies that we can now pick one of the bases, then raise the base. That is, A, pick one of the base, then raise it to the power. You are going to add the powers. A raised to the powers of what we have here, n plus n. This is your answer. Is that clear? Mind you, don't write it in this form, a n plus n. This is wrong. Please take note. Excuse me. Take note, because so this is how it will look like. Okay, assuming n is a real number, that is value, and n too is value. Let's fix idea with one example. Simplify simplify a raised to the power 2 times a raised to the power of 3. Amen? Okay? So, you can now see that at this point what we need to do, at first you write solution, then write the expression a raised to the power of 3. When you come across questions like this, at first what you need is for you to identify where this question is coming from. Amen? Yeah. When you look at it, you don't need a prophet to tell you. This question is coming from indices. And in indices, I mentioned it to you guys that when we have this, we have laws that are guiding indices before you'll be able to solve problems. So here, in between a raised to the power 2 and a raised to the power 3, what we have here, multiplication sign. The operation here is multiplication, true or false. So it means you are going to add the powers together, pick one of the base. So we have a raised to the power 2 times a raised to the power 3. We pick one, it means a raised to the powers of, we add the powers, raised to the powers of 2 plus 3. You know very well that we can add this and this to give us what? 5. So the final answer will now be a raised to the powers of 5. And don't write it in this form, a5. Is that clear? You are wrong. This is a5, while this is a raised to the powers of 5. Is that clear? Take note. Any question before we proceed? Do you have any question? Any question? Do you have any question? If you have any question, please drop it in the comment section. I give you 1 minute to ask your question. No question? So we can proceed, right? Can we proceed? Okay? Okay, let's proceed. Let's proceed. So whenever you come across questions of this form, note that this question is coming from indices and which of the law is applicable, the law that you can use to solve this type of question or problem is, you don't need a prophet to tell you, is multiplication law. Is that clear? Okay, before we proceed, I want us to learn something. In indices, as long as indices is concerned, when we have, note that when we have a raised to the power of minus 2, this is the 1 all over a raised to the power of 2. A raised to the power of minus 1 is the same as 1 all over a. Please take note. Are you following? Then if we have square root of a, this is the same as a raised to the power of 1 all over 2. It will help you take notes. Then if we have 1 all over square root of a, this is the same thing as a raised to the power of minus 1 all over 2. Please take note. What if we have cube root of a? This is the same thing as a raised to the power of 1 all over 3. Is that clear? It's very important. Then, assuming we have 1 all over cube root of a. So this is the same thing as a raised to the power of minus 1 all over 3. Take note, because this will guide you all through as long as indices is concerned. Not only indices, you can apply it in other mathematics. So you should take note of all this. As we proceed, more will come. Is that clear? Any question, please? Do you have any question? If you have any question, drop it in the comment section. No question? It means we can proceed, right? Okay. Let us proceed further to consider more example here. Okay, what if you are asked to simplify another example? Simplify a raised to the power of minus 2 times a raised to power 5. Yeah. Let's look at this. So what we need to do, we write solution. A raised to the power of minus 2 times a raised to the power of 5. Is that clear? So what we need to do is, since the operation in between them is what? Multiplication, right? So we apply the laws of multiplication. It means since the bases are the same, we pick one of the base. So here will now be equals to a raised to the power of minus 2 plus 5. Amen? Okay? Minus 2 plus 5. Minus 2 plus 5 is a raised to the power of plus 3, right? True or false? True or false? Any question, please drop it in the comment section. Do you have any question? Any question? You are not seeing well, Abba. Any question? Do you have any question? Any question? Yes or no? Yeah, we'll get to that if the bases are different. Is that clear? Okay, let's look at it. Let's answer this person's question. Assuming you are asked to simplify a raised to power 4 times b raised to power 3. You cannot do otherwise. Why? Because the bases are not the same. So you write solution a raised to the power of 4 times b raised to the power of 3 is equals to, excuse me, is the same answer, a raised to the power 4 times b raised to the power of 3. Please take note, because the bases are not the same. So you just leave it like that. Are you feeling? Yeah, sometimes your questions might not come this form. Sometimes they may say, example, simplify or evaluate a raised to power 4 and a raised to power 5. You don't need the prophet to tell you. You are still going to use multiplication law, because if we have a AA is the same thing as A times A. True or false? Then this is going to give you A raised to power what? 2. Amen? Okay? So when we have this, this is the same thing as A raised to power 4, A raised to power 5 is the same thing as the bases are the same. So we are going to have A raised to the power of 4 plus 5. This is equals to A raised to the power of 9. Amen? Any question, please? If you have any question, please ask. Emmanuel, Ibrahim, you still want me to come? Where? Okay, so let's proceed to consider division law. Let us proceed to consider division law. Division law. That is 2. Division law, right? Okay. Division law, when you have indices of this form, either A raised to the power n all over A raised to the power n, or A raised to the power n divides A raised to the power n. Whenever you come across something of this form, note that you are going to apply division law to simplify the expression. So let us fix idea with 1 or 2 examples. Example, simplify A raised to the power of 4 all over A raised to the power of 5. Yeah. You know, in multiplication, laws of multiplication, the multiplication law, it states that if the bases are the same, you subtract the powers. Is that clear? If the bases are the same, you do what? You subtract the power. So let's write solution. Our A raised to the power of 4 all over A raised to the power 5. This is equals to, since the bases are the same, you pick one of the bases. Base A. So raise it to the powers of what? 4 minus 5. So this is going to give us what? A raised to the power of 4 minus 5. We are going to have minus 1. True or false? Then this is the same thing as come here. A raised to the power minus 1 is the same thing as what? 1 all over what? A. Either you leave it like this or like this. Any question, please? Drop your question in the comment section. Drop your question in the comment section. If you have any question, I give you 1 minute to ask your question. 1 minute to ask your question. No question? So we can proceed, right? If there is no question, let us proceed. Okay. So this is how you are going to simplify these indices using division law. Is that clear? So let's fix idea with some examples. Okay. Let us fix idea. Let's fix idea. Simplify simplify 9 raised to the powers of 9 raised to the powers of minus 1 all over 2 and all over 27 raised to the powers of 2 all over 3. Amen? Yeah, it's simple as ABC. Let us solve it together. Right solution, right? Is a raised to the powers of minus 1 all over 2 all over 27 raised to the powers of 2 all over 3. Okay? There are so many ways we can simplify this particular problem. Is that clear? So now let us look at it together this way. You know, I told you guys that if we have a raised to the power of minus 1, this is the same as 1 all over a, right? Then what if we now have a raised to the power of minus 1 all over 2? This implies that this is the same as 1 all over either a raised to the power of 1 all over 2 or this is equal to 1 all over square root of a, because this is the same thing as square root. True or false? So if you can see what I am saying, then if we have a raised to the power of 2 all over 3, this is the same thing as cube root of a, open bracket, close bracket, raised to the power of 2. Amen? Yeah. Can you see? So let us simplify the numerator first. Apply this procedure. Then this is equals to, it means here will now be 1 all over 9 raised to the power of what? 1 all over 2. Then all over. Then here will now be cube root of 3 all in bracket, cube root of 27 open bracket, close bracket, raised to power 2. True or false? Any question? True or false? It's true. Right? Then this will now be equals to 1 all over. You know, I told you that when we have 1 a raised to the power of 1 all over 2, this is the same thing as square root of a. So look at it here. Here will now be square root of 9. Then all over. When we say cube root of 27, cube root of 27 means what is that value that you can use to multiply itself 3 times, then it will give you 27. Yeah. If I were you, let me show you how you can get it fast. Let's go back to our primary school. How to divide. If you want to divide 27, at first you think of the least number, true or false. Let us assume 2. You know that 2 cannot divide 27. True or false? So let's try 3. 3 to 27 will give us 9. Amen. Then 3 can still come again. 3 to 9, 3. Then 3 can still come again. 3 to 3, 1. True or false? Yeah. So you can now see that 3 into 3 places will give us what? 27. That is 3 times 3 times 3 equals to what? 27. Amen. So it means the cube root of 27 is equals to what? 3. That is cube root of 27 equals to 3. That is, it implies that 3 into 3 will give you 27. That is the meaning of cube root of 27. So now look at it here. Look at it here. As you can see, look at the board very well. Here, cube root of 27, but note that all in bracket raised to the powers of 2. So cube root of 27 is going to give us 3, but note that we have bracket raised to the powers of 2. Amen. Then this will now be equals to, let us ask ourselves, square root of 9. Now when we say square root of 9, square root of 9 means what is that value that you can use to multiply itself twice and it will give you 9. Let's still go back to our secondary primary school method. This is 9. Can 2 come? No, 2 cannot come. 3 can come, right? 3 to 9, 3, 3, 3 to 3, 1. You can now see that 3 times 3 is going to give us 9. So now the square root of 9 is what? 3. Why? Because 3 into 2. Any question, please? Do you have any question? No question, right? So far, so good. So here will now be 1 all over 3 all over. Here, when we have 3 squared, it means this is the same as 3 times 3. True or false? Which is equals to 9. So look at this place very well. So you can now see that we have 3 raised to the powers of 2. Then this is the same as 1 all over 3. Let me break it down for the sake of variance. Is that clear? Amen. Okay, so this is the same thing as 3 times 3. Yeah. So this will be equals to 1 all over 3 all over 3 times 3 will give us 9. Are you following? Okay. Yeah. So now, yeah, if you are not strong mathematically, you can stop here. But looking at it, it is not in order mathematically. Is that clear? So what we need to do is, if you can see what I am saying, note that this is 1 all over 3 divide 9. There is an invisible 1 here, right? So by the time you convert this division to multiplication, the denominator will now come top, will become the top, then the numerator will now become the denominator. So 1 all over 3 times 1 all over 9. So this is the same thing as 1 times 1 all over 3 times 9 equals 1 all over 3 times 9, 27. 1 all over 27. Or this is the same thing as 27 raised to the power of minus 1. Yeah. So any question, please drop it in the comment section. Any question? Do you have any question, please? Any question? Any question? question? Yes or no? How, okay. Yeah. How did you get 3 raised to power 2? Okay. It's okay. Yeah, let's look at it together. I was trying to explain this now for you. Look at it here. I said, listen. Let me take it all over again. Listen. When we have, that's why I said, if we have, this is called cube root of A. Is that clear? This is cube root of A. So we can rewrite this idiot in this form. A raised to the power of 1 all over 3. They are all the same thing. Do you understand? So now, if we have, assuming we have cube root of A, open bracket, close bracket, raised to power 2. It means this is the same thing as A raised to the power of 1 all over 3, open bracket, raised to the power of 2. Do you understand? So now, as I was saying, if we now have cube root of 27, then we have all in square. I told you that when we say cube root means what is that value that you can use to multiply itself? How many times? 3. And it will give you what is inside there. That is the meaning of cube root. Is that clear? So I now refer us to our primary school, how we normally divide. I said, let us, what is here? 27, right? 27. Then let's start with the least number, 2, right? 2 cannot divide 27. So let's move to 3. 3 to 27, 9. Amen? Okay. Now, we can still continue with 3. 3 to 9, 3. We can still continue with 3, right? 3 to 3, 1. Amen? You can now see that 3 into how many places? Look at the board very well. 1, 2, 3. It means 3 times 3 times 3 is equals to what? 27. Since we have 3 into 3 places, so now the cube root of 27 is equals to what? 3. Are you following? So here, look at it here. If you can see what I am saying, look at the board very well. You can now see that here there is bracket and all in what? Square. So it means inside this bracket is what? 3. So you are not going to remove this square. So instead of cube root of 27, you said it's 3. But it carries power. So it's going to be what? Raised to power 2. Then raised to power 2 means if we have this implies that this is the same as 3 times 3, which is equals to what? 9. Do you understand? And this is why we obtain 3 close bracket, 3 open bracket, raised to the powers of 2. Any other question, please? Any question? Okay, no question. Rabiat, you are just coming and you are telling me you don't understand. Okay, so let's proceed to consider another example that will help you. It's okay. Let's look at this. Simplify 1 all over 4, 1 simple as ABC. It's not difficult. Let's do it together. Let us do it together. Okay. The right solution, 1 all over 4 bracket raised to the power of minus 1 whole number 1 all over 2. Yeah. When you come across questions like this, what you need to do is what we need to do is, this is 1 whole number 1 all over 2. Use this to multiply 1, then add this. Add what is there. So here we are going to have 1 all over 4 close bracket raised to the powers of minus 2 times 1, 2 plus 1, 3. So 3 all over 2. Amen? Yeah. Okay? So if you can see what I am saying, this is the same thing as if we have 1 all over 4. Mind you, this is the same as 4 raised to the power of minus 1. True or false? It's true, right? So this is the same thing as 4 raised to the power of minus 1, open bracket, close bracket, raised to the power of minus 3 all over 2. Yeah. So use this to multiply this minus 1 times minus 3 all over 2. You are going to have 4 raised to the power of plus 3 all over 2. Then, you know, if we have a raised to the power of 3 all over 2, this is the same thing as square root of a, open bracket, raised to the power of 3. Take note. Amen? So if you can see what I am saying, this is the same thing as square root of 4, open bracket, close bracket, raised to the power of 3. Then, like I said square root of 4. When we say square root, what is that? That you can use to multiply itself 2 times and it will give you what is inside there. So you go to your primary school, 2, without a remainder, 2, 2, 1. It means 2 times 2 equals to 4. So the square root of 4 is what? 2, right? Okay? Okay, so far so good. So this is equals to square root of 4 is 2. But mind you, here is raised to power 3. So 2 open bracket, raised to power 3. This is the same thing as 2 times 2 times 2. Which is equals to what? Amen? So 2 times 2, 4. Times 2, 8. This is what you are supposed to have. Do you understand? This is how you are going to simplify it. Any question, please? Any question? Any question? Do you have any question? Please drop it in the comment section so that I'll look at it. No question. Okay. So we can proceed further to solve some examples, right? Okay. I love that. Yeah. Let's look at some good examples here. Let's look at some good examples here. Okay, simplify 27 raised to the power of 1 all over 3. 1 all over 3 close bracket raised to power 2 is simple as ABC. Amen. What we need to do, let's write solution first. So 27 raised to the power of 1 all over 3 raised to power 2. This is the same thing as, what we need to do. Either you do it this way, it's simple as ABC. I told you that if we have a raised to the power of 1 all over 3, this is the same thing as cube root of a. True or false? It's true. So if now we now have a raised to the power of 1 all over 3, close bracket raised to power 2. Amen? It means this is the same thing as cube root of a close bracket raised to the power of 2. So look at it here. So this implies that this will now be equals to cube root of 27 open bracket raised to the power of 2. Amen. And this is equals to. Are you following? This is equals to. I told you. Cube root of 27 is what? Is 3, right? So 3 open bracket raised to power 2, and this is equals to 3 squared, right? 3 squared means 3 times 3 equals to 9. Any question, please? Do you have any question? Any question? Any question? No question. Okay? So let's proceed to solve more examples. Okay. Let's consider division law. Let us consider zero law, right? Zero law. Let's consider zero law. Zero law, right? Okay? Zero law means that is if we have assuming x raised to power 0, x raised to power 0 is equals to 1. That is, it implies that anything raised to power 0 is always 1. Take note. So assuming you are asked to simplify cube root of 27 close bracket raised to power 0. Yeah. You don't need a prophet to tell you. You know why? Don't be panicked with what is inside here. What you after is the power. What is the power here? Is 0. So, assuming you are writing an objective mathematics question, you don't need to solve. You just conclude by go ahead to tick if there is 1. Just tick 1. Why? Because the law, the zero law, means that anything raised to power 0 is 1. It means half raised to power 0 is what? 1. Mathematically, yeah. 1 billion raised to power 0 is 1. 100 raised to power 0 is what? 1. Take note. 2 raised to power 0, 1. Take note, please. Write it down. Anything raised to power 0 is 1. Is that clear? Take note. It's very important. Do you understand? Then, let us consider power of a power. Amen. It means if we have indices of this form, x raised to the powers of a, close brackets, open bracket, raised to the powers of b. You can now see that this is power and this is what? Another power. So when you come across expressions of this form, what you need to do is to use the power to multiply each other. So here will now be equals to x raised to the powers of a times b. Mind you, please, it is not in this form, xa times b. Please take notes. You know, when you take, after taking series of wheat, what is on the board? You are writing it the way the wheat is controlling you. Please take notes. You people are very funny. And it's the reason why some of you fail mathematics. Okay, so can you see now? Amen. So take notes. Is that clear? So this is the same thing as x raised to the powers of a times b is ab. Take note. So I want you guys to simplify this. 2 mark. Simplify this. Simplify x raised to the powers of 2 raised to the powers of minus 3. Write the answer in the comment section. The first 5 people, please, I'm waiting for you guys. I give you only 1 minute. 1 minute. 1 minute. I'm going to award you mark. The first 5. Praise Ogbonna. You are just coming. Please, I want to see your answer. What is the answer? What is the answer, please? What is the answer? What is the answer, please? Write your answer. Okay? Savant, x raised to the powers of minus 6. Shew, x raised to the powers of minus 6. Yaya, x raised to the powers of minus 6. Fatima, x raised to the powers of minus 6. Okay? I think only Okay. I think you are right. Okay, yeah. So let's do it together. So it means this is equals to x raised to the power of 2 times minus 3. This is equals to x raised to the power of minus 6, right? Okay, you are right. Yeah. So let's solve one simple example. Then we call it a day because I'm going to welcome Mth2 students anytime soon. Is that clear? In the next 4 minutes or 5 minutes thereabouts. Is that clear? Okay, so let's look at this problem. Let's look at this problem. The combination of all the laws. So let's solve one. Simplify 4 raised to the power of minus 1 all over 2 times 16 raised to the power of 16 raised to the power of 1 all over 4. Open right. Oh, sorry. 3 all over 4. Then all over 4 raised to the power of 2. 4 raised to the power of 2. It's simple as ABC. Is that clear? So let's do it together. Write solution. 4 raised to the power of minus 1 all over 2 times 16 raised to the power of 3 all over 4 all over 4 raised to the power of 1 all over 2. It's simple as ABC. What I will advise you, you go back to what we have done so far. I told you that when we have a raised to the power of 1 all over 2, this is the same thing as square root of a. True or false? Yeah. Okay? So then if we have a raised to the power minus 1 all over 2, this is the same thing as, because of this negative sign, it will be 1 all over square root of a. True or false? Okay? So look at it here. We have 4 raised to the power of minus 1 all over 2. Amen. So we can rewrite this idiot in this form. 1 all over square root of 4 times 16 raised to the power of 3 all over 4. That is, if we have a raised to the power of 3 all over 4, this implies that we are talking about fourth root. So fourth root of a, open bracket, raised to the power of what is here? 3. Is that clear? Okay? So this will now be equals to 1 all over square root of 4 times fourth root of 16, all in bracket raised to the power of 3, sorry, all over square root of 4, right? Yeah. We are left with 2 minutes. So let us just utilize the time. Okay, so square root of 4 is what? Here is 1 all over 2 times fourth root of 16. It means what is that value that you can use to multiply itself up to 4 times, and it's going to give you 16. You go by this 16, 2, 8, 2, 4, 2, 2, 2, 1, 1, 2, 3, 4. So fourth root of 16 is equals to what? 2. But mind you, we have open bracket, close bracket, raised to power 3. So here is supposed to raise to power 3. So this implies that 2 times 2 times 2, which is 2 times 2, 4 times 2, 8, right? Okay, so here is now 8 all over square root of 4. is what? 2, right? So 2 to 8 is 1, 2 to 8, 4, right? So this is equals to 1 times 4 all over 2, then equals to 4 all over what? 2. 4 divided 2, 2. This is the answer. Is that clear? Any question? Do you have any question? So this is where we are going to stop. We meet on Wednesday, same time, same venue. Is that clear? Don't forget to take the attendance. See you guys on Wednesday. If you want to continue, no problem, because it's calculus. You are going to learn calculus your second semester. So if you don't mind, you can be part of the class. Yeah. So good evening. How are you? You are all welcome to calculus class. Yeah. We'll look at rules for differentiation, Mth211, that is calculus. Rules for differentiation. Rules for differentiation. Okay. Yeah. Before we consider rules for differentiation, let us know the meaning of differentiation. Differentiation means is the opposite of integration. Just like, let us use real life, man and woman. Yeah. So when we say the opposite of a man is what? Woman, two of us. So just like differentiation means the opposite of integration. Likewise, integration is the opposite of differentiation. So now let us have a function. Y is equals to ax raised to the power of n. Amen? Amen. So we call this y dependent variable. Amen? Any question? Yes or no? No question? Okay. Sorry for the break in transmission. So, let's proceed to solve, differentiate before we consider the rules of differentiation. Okay. If y is equals to 2x raised to the power of, okay, at first, let us define differentiation mathematically. Ax raised to the powers of n. So what we need to do, we write solution, right? Our y is equals to ax raised to the powers of n. Amen? Okay? So therefore, our dy all over dx will now be equals to, what do we have here? We have n here, two of us. Use this power to multiply the constant. So you are going to have an x raised to the powers of n minus what? 1. This is the formula for differentiation. Take note. And this is what we are going to use all through, as long as differentiation is concerned. So if you know this offhand, I don't think differentiation will be a problem. Is that clear? Any question? Please, if you have any question, drop it in the comment section. Any question? Yes or no? No question? Okay, let's proceed. Let us proceed. Let's proceed. Okay, let's proceed to consider some examples. If, if y equals to 2x raised to the powers of 5, find dy all over dx. Right? Okay? So this implies that solution y is equals to 2x raised to the powers of 5. So our dy all over dx is equals to, this is your n, which is what? 5. Then this is your constant, two of us. So use this n, 5, to multiply the constant. It means 5 times 2x raised to the powers of 5 minus 1, according to the formula. So it means our dy all over dx is equal to 5 times 2, 10x raised to the powers of 5 minus 1 is 4. Do you have any question before we proceed? That is all. That is all. Any question? Any question? Are you following? Are you following? So, as long as calculus is concerned, there are some questions they will ask you, you don't need to solve. You just tell them the answer. True or false? It's true. Okay, assuming you are asked to, if we have y equals to 5x raised to the powers of 4, then they ask you to find dy all over dx, right? You don't need the prophet to tell you. You can tell somebody that this answer is dy all over dx is equals to 20x raised to the powers of 3. True or false? You don't need to solve. So we write solution. Y is equals to 5x raised to the powers of 4. So our dy all over dx, since the independent variable here is what? Is x. What we have here, 4. Use this 4 to multiply the constant, 5. So you are going to have either 4 times 5x raised to the powers of 4 minus 1. True or false? According to the formula. So this is dy all over dx is going to be 4 times 5, 20x raised to the power of 4 minus 1 is 3. Please note that this is, don't write it in this form. Some of you, dy all over dx, your answer, you want to write it this way, 20x3. This is 20x3. This and this, they are not the same thing. Please take note. This is wrong. I'm going to mark you wrong. Please take note. Are you following? So take note. Is that clear? Any question, please? Any question? You have a question, drop it in the comment section. Please drop your question in the comment section. Any question, please? Do you have any question? Okay, so we can proceed, right? Sunday, Abel, no question, right? It's okay. Let's proceed. Let us proceed. Okay. Okay. I said we'll talk about rules for differentiation, right? Okay, now all of you rather, you now know how to differentiate function. True or false? You know how to differentiate function. What if we have a function y equals to 2x raised to the power 5 plus 3x raised to the power 4 plus 5? Yeah, what we need to do, we write solution. Our y is equals to 2x raised to the power of 5 plus 3x raised to the power 4 plus 5. You don't need a prophet to tell you, or you can just tell somebody this answer, that your dy over dx is equals to 10x raised to the power 4 plus 12x raised to the power 3. That is the answer. Know that this is a constant. What is here? 5. So whenever you differentiate a constant, it gives you 0. Take note. Very important. I know some of you want to ask, why is this 5 a constant? Yeah. The reason why it is called a constant, you can now see that in this function, we have the independent variable attached to this, true or false, which is x raised to the power of 5, the same thing. But here, you cannot find the independent variable, true or false. So that is why it is called a constant. Sorry, this is called a constant. Is that clear? So take note. So whenever you differentiate constant, it gives you 0. So it means your dy all over dx is equals to, according to the formula, what is here? 5. What is here? 2. So 5 times 2, 10x raised to the power of 5 minus 1. True or false? What we have here? Plus. What is here? 4. 4 times 3, 12x raised to the power of 4 minus 1. Then whenever you differentiate, this is a constant plus 0. But it's not necessary to write plus 0. You just leave it like that. Is that clear? So our dy all over dx is equals to 10x raised to the power of 4 plus 12x raised to the power of 3. Any question before we proceed? Please drop your question in the comment section. Any question, yes or no? Emmanuel, do you have any question? Any question? Please, after the class, don't forget to share. No question. Abdul Tawab, you said you have a question. Please ask your question. No question? Okay, Mohammed Usman, very straightforward, sir. Okay? I don't understand, sir. Please, Hope. Mark. Okay, you don't understand. Gaba, you don't understand. Yeah, as I was saying, I said, except you are just joining us. If you know the meaning of differentiation and the formula, I don't think you find it difficult. Those of you that are just coming, you are just joining us, and we have spent almost 20 minutes. I said, mathematically, if we have ax raised to the power of n, if we want to obtain the formula of differentiation, it means this is the dependent variable, this is independent variable. So our dy all over dx is equals to, use this power, what is here? N. Use it to multiply, what is here? A. So you are going to have an x raised to the power of n minus what? 1. I said this is the formula for differentiation. So it means with this formula, you can use this, you can use it to differentiate 2x raised to the power of 5 without using your biro. You can tell somebody the answer, true or false. It's true, right? So now it means our dy all over dx is equals to, what is your a here is 2, right? What is your n here is 5, right? So look at it. Let us apply this here. So it means use this 5 to multiply this 2. So here will now be 5 times 2x raised to the power of 5 minus what? 1. True or false? Is true. Then this is dy all over dx is equals to 5 times 2. 10x raised to the power of 5 minus 1. 4. This is all. Is it difficult? No. It is not. Then, now I said, if we have a function of this form, y equals to 2x raised to the power of 5 plus 3, and you are asked to find dy all over dx. This means that this is a constant. Why? Because the independent variable, you are not seeing the independent variable attached to this 3. So it is a constant. And I said whenever you differentiate a constant, it gives you 0. Take note. So here, our dy all over dx is equals to, we apply the same approach here, which is 5 times 2x raised to the power of 5 minus 1, then plus, this is a constant, plus what? 0, because whenever you differentiate a constant, is 0. So therefore, our dy all over dx is equals to 10x raised to the power of 5 minus 1 is 4. Plus 0 is not necessary. You leave it like this. So we are going to use the same approach to differentiate this. Any question before we differentiate that one again? Do you have any question? Any question? No. No question, right? Okay. So Far so good. So let's differentiate this. Y equals to 2x raised to the power of 5 plus 3x raised to the power of 4 plus 5, right? So we are going to approach this idiot the same way. This is your n, this is your a. Use it to multiply. You are going to have 5 times 2x raised to the power of 5 minus 1. True or false? True or false? It's true. Plus the same thing, 4 times 3x raised to the power of 4 minus 1. When you differentiate a constant, it gives you 0, right? So our dy is not necessary we write plus 0. It is not necessary. If you say you want to write it, no problem. So our dy all over dx is equals to this times this 10x raised to the power of 5 minus 1, 4, plus 4 times 3, 12x raised to the power of 4 minus 1, 3. This is the answer. Is that clear? Okay? So far, so good. That is that. So now, before I move to the rules, let us look at derivatives. Derivative. That is when we have dy all over dx. This is the same thing as y prime. You not only dy all over dx that you will see. Is that clear? Sometimes they will ask you to find y prime. Is that clear? So, and this is the same thing as in physics, y dot. Sometimes they will say, or y dot is the same thing. So we call this first derivative. First derivative. This is known as first derivative. Then d squared y all over dx squared. It means this is the same thing as y prime prime, and this is the same thing as y dot dot. This is known as second derivative. Is that clear? Second derivative. Take note. Are you following? This is second derivative. This is second derivative. Is that clear? Then, when we have d cube y all over the x cube, this is a third derivative y prime 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 equals to y dot dot dot. This is a third derivative. Are you following? Do you understand? Third derivative. So assuming you are asked to, if y equals to 2x raised to the power of 5, then they now say find y prime, comma y prime prime, up to y prime prime prime. It's simple as ABC. What you need to do here is, it means differentiate this function 3 times. So you write solution, right? Our y prime will now be equals to, use this to multiply, that is 5 times 2x raised to the power of 5 minus 1, which is y prime is equals to what? 10x raised to the power of 4. Then you differentiate your y prime to obtain y prime prime. Is that clear? So y prime prime, you are going to differentiate the answer of y prime to obtain y prime prime. It means what we have here, 10x raised to the power 4. This is your n, this is your a. Use it to multiply, that is 4 dot times 10x raised to the power of 4 minus 1. True or false? So your y prime prime will going to give you 40x raised to the power of 4 minus 1, 3. Then they said we should consider up to y prime prime. So y prime 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 will now be equals to, you are going to differentiate the answer of y prime prime, which is 40x raised to the power 3. Then use it to multiply this 3 times 40x raised to the power of 3 minus 1. Then y prime 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 will now be equals to 120x raised to the power of 3 minus 1. You are going to have 2. True or false? So this is how to differentiate up to y prime. Then if you want to differentiate up to y iv, what should be the answer? Somebody differentiate this y iv. What is the answer? Write it in the comment section. I'll give you 2 marks. I'm waiting for you. 2 marks. What is the answer? Two marks is waiting for you. Yeah. Hussein. I love that. Abdulkader Hussein. Please remind me in class. Emmanuel, remind me in class. You are going to have 2 marks. You have 2 marks. Okay. Yeah, you are right. These 3 persons. So now let us move to, hope you are enjoying the class. Let's move to rules for differentiation. We have 3 rules. 1, product rule. Product rule. 2, quotient rule. Quotient rule. 3, chain rule. But I call it substitution stroke chain rule. And this is also known as function of a function, or function of a function. Yeah, chain rule is also known as what? Function of a function. It's very important. So, if you know all these rules, when and how to apply them, whenever you are given a function, I don't think calculus will be difficult for you. Is that clear? So we are going to take one after the other. Do you understand? Are you following? Do you understand? Okay. So far, so good. Let's start with product rule. How to apply or use product rule and differentiate is simple as ABC, right? Okay. Product rule. The formula for product rule is the function is always in this form, uv. Is that clear? uv. It means when we say product, you know the meaning of product in mathematics. True or false? Product means what? Multiplication, times. True or false? That is, look at this. This is a function. You see that this is one function, this is another function. It means whenever two functions coming to multiply each other, note that the rules you are going to apply is product rule. And the formula is our dy all over dx is equals to u dv all over dx plus v du all over dx. Take note, this is the formula for product rule, or this is the same thing as dy all over dx. In some textbook, you will see v first, v du all over dx plus u dv all over dx. They are all the same thing. Either you apply this or this. They are all the same thing. Is that clear? So we are going to fix idea with examples. We will fix idea with examples. Is that clear? We'll fix idea with examples. Okay, so let us consider some examples since you know how to differentiate function. So let us fix idea. Yeah. Okay. But before we use product rule, let us, if we have y equals to sin x, our derivative of sin x dy over dx is equals to cos x. Then if we have y equals to cos x, the derivative of cos x dy all over dx is equals to minus sin x. Then tan x is sec square x when you differentiate tan x. Take note. So let's take note of this. Okay, so let us fix idea with one example using product rule, because sometimes they will not ask you, they will not specify use product rule. They will just give you the function and ask you to find the y all over the x. So it is left for you to recall the rules. Which of the rules is applicable so that you won't have any problem. So let's fix idea with example. If y equals to 3x squared, if y equals to 3x squared close brackets, open bracket, sin x, and they said find dy all over dx. It's simple as ABC. Amen? Yeah, so what we need to do here is we write solution. Our y is equals to 3x squared. What if there is no brackets? Sin x. You can now see that you don't need a prophet to tell you. You can now see that this function, you are going to apply product rule. Why? Because look at it. This is look at it. This is a function on its own, and this is another function. So you can now see that they are multiplying each other, two of us. So you are going to apply product rule. And product rule is of this form, uv. Two of us, then the formula is dy all over dx is equals to u dv all over dx plus v du all over what? Dx. Two of us is true, right? So now you have to compare this and this. Look at the formula. You have to compare this and this. You don't need a prophet to tell you which one should be your u and which one should be your v. We now see, let u be equals to 3x squared and v be equals to sine x. Amen? True or false? Are you following? Are you following? Are you following? Do you understand? Okay? So now, you now say let u equals to 3x squared and v equals to sine x. So look at the formula now. You have your ordinary u as 3x squared. You also have your ordinary v as sine x. What is left? The v all over the x and the u all over the x. So it means you are going to differentiate this function respectively. So with respect to x. So our du all over the x is equals to 6x, because 2 times 3, then 2 minus 1 raised to power 1, but it's not necessary. And the v all over the x, as it is written here, is cos x. So far, so good. So what you need to do, you recall the formula. Our dy all over the x is equals to, in the formula, what is the ordinary u? Is 3x squared. Then the v all over the x is cos x times cos x. Then what we have here? Here is plus, right? Plus, then what is v? V is sine x. Then what is du all over the x? Du all over the x is 6x. This is the answer. It's simple as ABC. Or we can write it this way: dy all over the x is equals to 3x squared cos x, then plus 6x sine x. Please don't ever write sine x 6x. Mathematically, it is wrong. But write the value before the trig sign. Is that clear? So, any question, please? Do you have any question? Any question, yes or no? Please, do you have any question? Any question? Do you have any question? No question. It means we can proceed, right? Okay. Let us fix idea with one example again before before we consider one example, let us have this first. Let me teach you how to differentiate. Assuming we have, if we have sine 3x, then find dy all over the x. It's simple as ABC. What you need to do is you write solution, right? Y is equals to sine 3x. So our dy all over the x, dy all over the x, now be equals to, what do you have here? 3, right? Then, just assume that this is how it is, sine x. That is in the spirit. Just assume that this is how it is. Is that clear? Sine x. If you differentiate sine x, what are you supposed to have? You are supposed to have cos x. True or false? It's true. But now, we have sine 3x. So if you are to differentiate sine 3x, you are going to have 3 cos 3x. Take note. This is the answer. So supposing you have y equals to sine 1 over 2x. What are you supposed to have? Because you know that if you differentiate sine x, you are supposed to have cos x, true or false? So for this reason, our dy all over the x, we are going to have 1 all over 2 cos 1 all over 2x. Please take note. Then, what if you are asked to differentiate y equals to cos 3x? If you differentiate cos x, excuse me, you are supposed to have minus sine x, true or false? So your dy all over the x, you are going to have minus 3 sine 3x. Take note. Take note. Any question, please? Any question? Okay, so we can proceed, right? Okay, let us proceed. Let's proceed. So, clear this. Let us proceed. We are still under product rule. Let's proceed to solve one problem here. If y equals to 2x squared, 2x cubed, if y equals to 2x cubed times cos 3x is simple as ABC. You can now see that you don't need a prophet to tell you. We have two functions multiplying each other, true or false? So what you need to do, you have to apply product rule. So we write solution, amen. Y is equals to 2x cubed cos 3x. And the formula is uv, that is our dy all over the x, is equals to u dv all over the x plus v du all over the x. True or false? So at this point, you don't need a prophet to tell you what is your u. You now say let u be equals to 2x raised to the power of 3 and v be equals to cos 3x. So what left is for us to differentiate this with respect to x. So it means your du all over the x is going to give me 6x raised to the power 2 and the v all over the x, you are going to have minus 3 sine 3x. Right? So what we need to do is for us to substitute this into the formula. Any question? Any question? Gentlemen and ladies, do you have any question? No question? Okay, let's proceed. So, let us proceed. So let us substitute into the formula dy all over the x is equals to, here we have an ordinary u as 2x raised to the power 3 times dv all over the x is minus 3 sine 3x. Then what we have here plus, what is ordinary v is open bracket cos 3x. 3x times du all over the x is 6x squared. You leave it like this, or this is the same thing as dy all over the x. You multiply out this 2 times minus 3 minus 6x then plus this times this 6x squared cos 3x. This is the answer. Any question? Do you have any question? Or, something is common here. 6x squared, two of us. So, we can write dy all over the x is equals to factor 6x squared out. Then here will now be x sine 3x plus, here it will be minus, then cos 3x. Or you leave it in this form. Any question, please? Any question? The camera is not clear. I think that should be from your network. I think so. The camera should be clear. Check your network. The camera is clear. Okay, so that is product rule. So let us move to consider quotient rule, right? Let's consider quotient rule. Quotient rule 2. Quotient rule. Yeah, ask yourself this question. What do you mean by quotient? When we say quotient, quotient means division. Is that clear? Division. That is, if you have something of this form, we can refer this as what? Quotients. Is that clear? So if two functions divide each other, that is when you can apply quotient rule. And quotient rule is of this one, u is equals to, y is equals to u all over v. You can now see that this function is dividing this function. Then the formula for quotient rule is dy all over dx is equals to u dv all over dx minus v du all over dx all over v squared. This is the formula. Is that clear? Is that clear? This is the formula. So far, so good. Let us fix idea with an example. 4 sine 5x. Okay. If y equals to 4 sine 5x all over 5x raised to the powers of 4. Now say find dy all over the x is simple as ABC. Is that clear? Okay. As simple as ABC. So let us look at it together. Let's look at it together. So, yeah, we'll call it a day. Nepals. Taking lights.